Hi, I'm FullDeck.
And I'm missing a few cards, and we're here to do a demo solve of a puzzle that we were fortunate enough to come in on near the end. BremSter had been setting this lovely puzzle, and we contributed a few ideas towards the completion of it, and we thought we'd give a demo solve of it.
Yes, so definitely not a blind solve.
Absolutely.
But what we're going to try to do is showcase the logic as we go along. So this is Darling Fountain, and what we have for rules are normal Sudoku rules apply. So in every row, in every column, and in every 3x3 box, we have to place a complete set of the digits 1 through 9.
Digits in cages must sum to the number in the top left corner of the cage. Digits may not repeat in the cage, so this is standard cage rules.
Standard cage rules, but for example, in this 9 cage, although we could make 9 as 4 plus 4 plus 1, we cannot put 2 4s in the cage even though they don't see each other. So we'd have to have 3 separate digits summing to 9 in this cage. We also have Nabner lines. And so Nabner lines, this is the word Renban reversed. So on Renbans, you have to have a set of consecutive digits. On Nabner lines, you cannot have any pairs of consecutive digits. So no 2 digits on a gold line. So for example, this gold line, no two digits on that gold line can be consecutive regardless of their position on the line. We also can't have any repeating digits on the line. So if, for example, this were a 7, we could not have another 7, nor could we have a 6 or an 8 anywhere on the line. Those are the rules, and we will restart the puzzle to restart our time.
And let's give this a whirl.
Let's do. Well, we know that we're not exactly giving it a whirl because we know we've solved it, but we will try to give it a whirl in terms of showcasing the logic.
Let's give it a whirl.
Let's give it a whirl.
Actually do a good solve.
Absolutely. All right, here we go. So we know that the place to start is with the 7 cage. There's only one way of making 7 in 3 digits that are distinct, and that would be 1, 2, and 4. If we reduced any of these, we wouldn't get to 7, and if we change any one of them up, we don't have any flexibility for where to go with that. So 1, 2, and 4.
Yeah, and of course the 1 and the 2 can't be consecutive on the gold line, so we must have a 4 on the line, and we can't have a 4 in row 2, column 2.
Okay. Now, if we look over at the 9 cage, there are 3 ways of making 9, and all of them in 3 digits, and all of them are going to interact in interesting ways with the 7 cage to force digits up into row 1 of box 2. So a 9, and we're just going to go through the possibilities here and show why they would cause problems, because we can actually determine the composition of this 9 cage now. 9 could be 1, 2, 6, but if it were 1, 2, 6, then where do 1 and 2 go in box 2?
Well, let's talk about the composition of a 15 cage so that we can then use that.
Okay, let's do that.
A 15 cage, and this is an observation BremSter made a month or so back in some puzzles he set to showcase this, and that is a 15 cage has the lovely property that either the digits in there are entropic, meaning there's 1 low, 1 middle digit, and 1 high digit, or they are isotropic and all mid, 4, 5, 6.
Yes.
So either there's a low digit, a middle digit, and a high digit, or they're all mid digits.
And so one of the points that he makes with this is if you had 2 low digits here, even the biggest 2, 2 and 3, you would need then a 10 to complete the cage. So we can't have 2 low digits up here. Yep. And that's deeply important for this puzzle.
And that's what we're about to use.
Exactly. So if we had the 9 as a 1, 2, 6, then 1 appears in rows 2 and 3 in boxes 1 and 3. So where does it go in box 2? It would have to go in row 1, as would 2, because we also have 2s locked into these into rows 2 and 3 in boxes 1 and 3. So we would have to have both 1 and 2 in the 15 cage, which, as Missing just explained using BremSter reasoning, cannot happen. So we cannot have a 1, 2, 6 combination for this 9. Another possibility would be 1, 3, 4. I'm sorry, 1, 3. I'm sorry, 2, 3, 4. That's what we're looking for. 2, 3, 4 is another of the 3 possibilities for making a 9 cage. If that happens, well, then we would have to we have 2 and 4 both locked into these cages. So we would have to have 2 and 4 up here. Now, but where?
On the Nabner line in box 3, we'd have to have the 3 off the line in order to separate And so those would have to be a 2-4 pair.
Mm-hmm.
And that would mean...
That can't be 2 or 4 because they both appear already on the Nabner. And on this, well, we have a 4 on the Nabner in one of these 2 cells, so that one can't be a 4.
And it also can't be a 2 because we have either 1 or 2 on the Nabner line, and that would rule out 2 by being either the same digit or consecutive.
So that means that this cell would have to be both 2 and 4, and this is not a Schrodinger puzzle.
No.
So we have now ruled out 2, 3, 4. That only leaves the possibility of 1, 3, 5 for the 9 cage in box 3. And so that's what it has to be. It has to be a 1, 3, 5. But now we do have 1 locked into these 2 cages, which forces a 1 into the 15 cage in box 2.
Now, just as before, it can't be in column 4 because we have either a 1 or a 2 on the Nabner line already.
Yes. It could at the moment still be here because it could be that the 1 is over here in row 2, column 8 with a 3, 5 on the Nabner, and then a 1 would be perfectly fine right there. So, nice start with interactions of cages and Nabners to force some things happening up in this 15
I think
cage.
I can place the 1 now.
Can you place the 1?
I think so, because if the 1 was in column 6, that would force the Nabner line to have 3, 5 in the box in the 9 cage. So we'd have 1, 3, 5 on the Nabner line, and then the lowest digit we could have in row 4, column 9 would be a 7. You can't make a 9 cage with a 7 in it.
Okay, well, that's very nice reasoning. I had not
we
seen
had not
that
seen
before.
before.
We had not seen before. So the 1
Please,
cannot
that-
go there. That is not the solve path we intended to take, but it works.
Yeah.
So where we have gone with this puzzle next, not seeing that lovely reasoning there, preventing the 1 from being in this spot, was actually to look down at the 8 cage. And an 8 cage in 3 cells is either 1, 2, 5 or 1, 3, 4. And either way, there is a 1 in this cage. And since there's a 1 trapped into columns 7 and 8 in boxes 3 and 9, that means that the 1 in box 6 has to be in column 9, which puts it in the 9 cage.
Yep.
And now, we just said some things about that 8 cage. Let's do the same kind of reasoning that we had before when we were looking at the 7 and 9 cages and what that did to box 2. Let's do the same thing for these 2 cages and look at the implications for box 6. So if this 8 cage is a 1, 2, 5, well, the 1 and the 2 can't both be on the Nabner. So that would put a 5 on this Nabner. And now we would have 5s. Well, it doesn't matter that it's on the Nabner.
We'd have a 1 and a 5 in the 9 cage, so it would have to be a 1, 3, 5 combination.
In the 9
so that's
cage.
one possibility.
My apologies for going the wrong direction with that, but yes,
So if there's a 5 in the 8 cage, the 9 is a 1, 3, 5.
Yes.
Now what happens if it's a 1, 3, 4?
If it's a 1, 3, 4, then there is. Let me take the 5s off of here because we don't. That was irrelevant. This particular part of the solve. If there's a 1, 3, 4 here, then we have 1 and 3 both locked into these columns, which would put a 3 in the 9 cage. Once we have a 1 and a 3 in the 9 cage, we also need a 5 to complete the sum.
So either way, the 9 cage is a 1, 3, 5.
Absolutely is a 1, 3, 5. Now, previously, this was how we ruled the 1 out of this spot. So your finding there was really quite lovely. Let's look a little bit more at what's happening with this 8 cage. I'm going to take away the colors.
So we have a 1, 3, 4, 5 quad in column 8.
Well, we don't because we've taken out the 1, 2, 5 possibility. So this is either 1, 3, 4 or 1, 2, 5. I'm sorry. Yes, 1, 3, 4 or 1, 2, 5. So let's look at the different possibilities.
Yep.
I know, because we were just playing around with what can happen where. So let's now be a little bit more careful with this. If this is a 1, 3, 4, we cannot have 3 and 4 on the line. So we would have the 1 on the line along with either a 3 or a 4, and there would be a 3 or a 4 down here.
Yeah, but that would cause problems.
Yes.
Because we'd either have...
So the 1, with the 1 already on here, that makes this a 3, 5. And whichever one it is consecutive with 4. So we would actually have to have 4 off the line. So the 4 would have to be here, and we would have 1 and 3 on the line.
Yes.
So that's one possibility. if we have a 1, 2, 5, then we have a 5 on the line because we can't have both 1 and 2 there, which means that the 5 comes out from this cell. We have a 1 or a 3 there. The 2 can't be on the line. So if it's a 1, 2, 5, the 2 is here, and the 1, 5 are on the line. And that gives us a 1, 3, 5 triple on this Nabner. And now it's time for some colors.
Yes. Let's look at row 2, column 8.
Well, I'm going to go ahead and give colors to all 3 of these because that will help me at least see what's going on. So these are, the digits cannot repeat in this 9 cage. So these are 3 distinct digits.
But also, the digits can't repeat on the Nabner. So those 3 digits on the Nabner line are a set that consisting of 1, 3, and 5. And row 4, column 9 cannot be the same as yellow or pink, so it's blue.
Beautiful. And now we also have this set of 3 digits from 1, 3, 5.
Which means that row 7, column 8 can't be blue or pink, it must be yellow.
Okay. And now this cell
sees blue and yellow.
Sees blue, sees yellow. That one must be pink. This one must be yellow. And now this set of 1, 3, 5, this cell sees yellow and pink, and it has to be blue. And this is part of the puzzle that Brem built before we ever saw it. And it's just
lovely,
stunningly beautifully built.
Yep.
So thank you, Brem, for building this puzzle.
So now we can look at column 6, rows 1 and 9, because we have 1, 3, 5s on Nabner lines. So those have to be 7, 8, or 9.
7, 8, or 9.
And in row 1, if it were 7, with a 1, we need another 7 to complete the 15 cage.
Yes,
so that can't be 7.
And we do need to make another 14. And also using Brem's logic, we've got our low, we've got our high. This is going to come from the mids. And we need to sum to 14. So if this is an 8, we need 6. If this is a 9, we need 5.
But we can't put 5 there because of the 4 on the Nabner line.
Yes, so this has to be a 6. That has to be an 8. And we can take 8 off down there. All right, so let's play a little bit more with what's going on with these. Actually, no, we're not ready to do that yet. Sorry, my apologies. We now need to come look over here in the 19 cage. So, or actually in the 11 cage. Let's look at the 11 cage. An 11 cage has to have either a 1 or a 2 in it, because if it didn't have a 1 or a 2, the smallest we could make would be 3, 4, 5. 3 plus 4 plus 5 is 12. So we have to have either a 1 or a 2.
And unfortunately, if we had a 1 in there, there'd be 1s in columns 2 and 3 locked in, and that would force a 1 in the 19 cage, which would mean we need 2 9s to make 19.
It would.
So that can't have a 1 in it.
So that means we do have a 2 in the 11 cage, and that 2 is now locked in with the 2 that's in the 7 cage, forcing a 2 into the 19 cage.
And it can't be in row 4 because it's...
Well, I was going to first go with the fact that a 2 in a 3-cell 19 cage has to go with 2 digits that sum to 17. It's going to have to be 2, 8, 9.
Yeah.
So let's get the 2, 8, 9 in there and then talk about what can't be where.
So the 2 can't be in row 4 because we've got either a 1 or a 2 on the Nabner line already, and that would either be equal to a digit or one apart.
Yes. So now this 11 cage with a 2 in it, it's either 2, 3, 6 or 2, 4, 5, because it does not have a 1. And the 1, 2, 8's been ruled out because we know there's no 1 over in the 19 cage.
If it's a 2, 3, 6, one of the 2 and 3 is on the Nabner line, and the other is off the line. But either way, there is a digit within one of 2. So that cannot be a 2 in that case.
Yes.
If it's a 2, 4, 5, one of the 4 and 5 must be off the Nabner line, and therefore there's a 2 on the Nabner line.
But more importantly, also, if it were a 2, 4, 5, we would have to have a 4 in this cage.
No.
Because we would have 4s locked into columns 2 and 3.
Okay, so let's rule that.
So it is not 2, 4, 5. It is 2, 3, 6. And so now
there's either a 2 or a 3 on the Nabner line, which rules out the 2 in row 6, column 1.
Yes, and this is not a 6, because there has to be a 6 along with the 2 or 3 there. But this is not a 2. And now this 8, 9 pair places the 2.
Okay, so now what can we put in row 9, column 4?
what can we put in row 9, column 4?
So could it be a 4? Perhaps. If we had 2 and 6 on the Nabner line in the 14 cage, we could conceivably put a 4 there.
We could.
Otherwise, it has to be at least 8.
Well, we know that we do not have a 2 or a 3 in this spot. Nor do we have a 5 or a 7. We don't have a 2 or a 3 because we have either a 2 or a 3 here.
It could be 1, couldn't it?
It could be 1. So we don't have this cell sees either 2 or 3, so cannot be 2 or 3. It sees 6, so it cannot be 5 or 7. And it sees an 8-9 pair, so it can't be 8 or 9. So it is either 1 or 4. Now, there are very few possibilities then left. So if this is a 1 with a 7, that makes 8. We would need an 8 here. If this is a 1 with a 9, that's 10. We would need a 6 here. 4 with a 7 is 11. We would need a 5. And 4 with 9 is 13. We would need a 3. For the moment, we're going to leave all of those.
In fact, what do we know? No, we don't know about the 8 cage yet.
However, what we do know is that this is 2, 3, 6. If this were
either
one,
a 2 or a 3.
If this were a 1, 2, 5, we would have to have a 2 in this cage, and we don't.
Yes.
So this does have to be a 1, 3, 4, which places the 4 right there, and makes this a 1, 3 pair, which makes that a 5.
We've forced a 3 into the 16 cage.
And we have forced a 3 into the 16 cage. There's a 3 here. There's a 3 there. They're locked in. And that means that this has to be a 3. And that is, my friends, is going to actually completely determine this cage. We do have to have the 3 with the 4 and the 9. But we also now know that pink is 5. And so we can take 5s out of yellow and blue.
And oh, look, that gives us a 1, 3 pair in row 2.
Isn't that lovely? So this 1, 3 pair now knocks 1s out of these cells.
Makes them 2 and 4 respectively.
2, 4, and 1. And now the 2 looks down and takes 2 out of those cells.
Which places all 3 of them.
It does. 3 and 6 and 2. And now the 3 looks over and gives us the 1 and the 3. And now yellow is 3 and blue is 1.
And I think we can get rid of the colors.
I think we can get rid of the colors. But again,
that was just
all of that.
BremSter,
all of that was Brem. This is what what had already been constructed in the puzzle, actually even beyond this, before we even saw it. And this whole logic is so stunning and so beautiful, and we're just very excited and pleased to be part of looking at this puzzle. So
what about the 9 cage?
What about the 9 cage? Yeah. It sees a 4 in both spots, so it cannot be 2, 3, 4. That means there is a 1 in the cage. So we do have a 1 in this cage. It's either 1, 2, 6. If it's 1, 2, 6, the 6 can't go here. The 6 would have to go there. And then we would have a 1, 2 pair. Or it's 1, 3, 5. And if it's 1, 3, 5, the 5 is looking across. So the 5 would have to go there. And this would be a 1, 3 pair. So very limited possibilities for this cage. And particularly once we look at the fact that this is a Nabner. So once we determined...
Well, it's either a 6 or a 5 on there.
Right.
So the Nabner won't be restricted.
You're right, actually. I'm sorry. But the fact that there is a Nabner line here does help with some other things down the road, as I recall. So.
Should we do some Sudoku?
Well, we certainly could, but can we first look at the nature of this box 5?
Okay.
Because this is 18, that's 12, that's a total of 30. So we have a hidden 15 in here. And
it's got to be entropic.
It has to be entropic because we already have a low. So one of these is going to be high and the other is going to be mid. And that's just something we want to keep in mind for down the road. It's going to help a little bit when we get there, when we're further down the road. Just an observation for the moment. But you want to do some Sudoku.
Yeah,
so
let's place a 4 in box 7.
Yes, so 4 is looking across, taking 4s out of those spots. And this 4 looking down, so that's a 4. And now I think we should also maybe look at 8s looking up and 8 looking across, giving us an 8.
And giving us an 8 in box 3.
And now Okay, 8's looking across. 8's looking across. That's an 8. And 8's looking down, and 8's looking down, giving us an 8 here. And now 8 looking across, 8 looking down, giving us an 8 right there. So lots of stuff happening with 8's. And I think we can do something similar with 9's. So 9 is looking across, 9 is looking
That
down.
pointing pair of 9s there is very
It's
powerful.
very powerful.
And now in box 1.
Yep, 9 looking up, 9 looking up. That's a 9.
And 9's in box 9.
9 looking across, 9 looking across, placing a 9. And now
And
9 looking up, and 9 looking across, placing a 9. So, very nice construction there from Brem. Let's see, what else can we look at for Happy Beauty? Well, 3 and 6, and 1, 3, and 6 in box 4 can't be in column 1, can't be in column 2. So this is a 1, 3, 6 triple in column 3. This one's not a 1 and that one's not a 3. And so we're left in this column with 4, 5, and 7. Do a little Sudoku to clear our throats before we move into the center box.
What's the rest of column 3?
Rest of column 3. We have
7.
1, 2, 3, 4. We're missing 5. We've got 6. We've got 8 and 9. So yes, 5 and 7. Oh, I think we should probably jump into looking at, well, actually, no, we have more Sudoku that we want to do first, as I recall. 5's in box 9. Those are looking down. So this is a 5, which unwraps the 7, 5 pair in column.
And we can complete
3.
box 7 now.
And box 7
Needs a 5.
and a 1, and this one will determine the order, or the 5 below it will determine the order. So we get the 5 and the 1 there. These are 3, 6, and 7.
We can take 6 out of row 1 and 3 out of row 2.
Beautiful. And in box, in row 9, we are missing 2 and 6, which for box 9 leaves us with a 7. And so these now are 1, 2, 5.
No 1 in column
And no
5.
1 in the, yes.
And row 6, row 9, again, row 8. 6, 7, 8.
And this one's not a 6, and that one's not an 8. Okay. Now, column 9 is missing 2, 4, and 6. So this one's a 2, 4, and this is a 2, 4, 6. In fact, where does 3 go in row 1? It does not go in any of those. So this is the 3, leaving us with a 6, 7 pair. And these are 2, 4, and 7.
Where does 6 go in box 3?
So 6 in box 3 goes right there, which comes down and unwraps the 2, 6 pair. 2 looks back up.
And the 6 in row 3 looks across.
6 in row 3 does look across, gives us a 7 and a 6. And now we're missing, let's go ahead and put in the triples. We are missing here 5, 7, and 9. And this one is not a 9. And here we are missing
2, 3, and 7?
2,
No,
3.
2, 3, and 4.
Yes, 2, 3, 4, which is lovely because with this being a 2, 3, or 4, that cannot be a 3.
Yep.
It would either be consecutive with 2, a repeat of 3, or consecutive with 4.
Logic.
Absolutely stunning. So that's a 6, which gives us a 1, which gives us a 3. And now this has to be
1, 3,
a 1,
5.
3, 5. This is the only place for the 5, and that's a 1. The 5 unlocks the 2 and the 1. And now we can look up and do a little bit more Sudoku. That's not a 2, and that's not a 5. Let's see where.
Now the 15 cage. That one cannot be 4, 5, 6.
If it were 4, 5, 6, we would need a 6 down here, which is ruled out by that 6. So since it's not 4, 5, 6,
it must be low, medium, and high.
Yes.
And it sees 8 and 9 in
Yes.
both columns. So it has to have a 7 on it.
it does. And that 7 then is going to take 7 out from here. And it does place a 7 in one of those two. I don't usually mark across boxes, but it's in a cage, so we're going to do it that way.
Yep.
7 with 2 would require a 6, which would have to go there.
7 with 4 would require another 4, which can't work. So that's not a 4.
Well, it's also not a 2 based on what we just said.
Yes.
So so 7 and 4 would require another 4. 7 and 4 would require a 6 that's blocked out. So this has to be a 3.
That's lovely.
3 with a 7 and a 5. So this is now a 5-7 pair, but the 5 looks up and places the 7 here and the 5 there.
And the 7 looks up.
And the 7 looks up, so does the 5. So the 5 looked up to this 7, which gave us the 9 and the 5. This 7 is looking up to give us the 2 and the 7.
And
This 3 is looking left to give us a 4 and then a 2. Okay.
And the 5 and 7 are looking left. Well, the 7 has already done it, but that's a 4.
That is a 4.
Which resolves that column.
7 and 5. And now, go ahead.
I was going to say exactly the same thing you were
Okay.
going to.
So now we have our low, we have our mid, we need a high, and we actually know which one it is because 1 and 5 is 6. We must need a 9 right there. All right.
It's still not unraveled the 19 cage.
It has not.
But we will soon.
We
That's,
will.
4 and 6.
4 and 6.
And the 12 cage.
Let's
the
do a
7
little
gets.
more Sudoku. So this 7 looks down and gives us a 6. We now have a 7-8 pair, not unraveled yet. But these
will.
are 2 and 4. And that's
Placeable,
a
next
6.
to the 2.
Okay. I was just going to go for the cage first, but that gives us 6 in the 12 cage. We need another 6. That's going to unravel a 4 here and a 6 there. We still need an 8, 9 in this row. And we in this box now, we have 3, 7, and 8, which fortunately do sum to 18. That would have been distressing had they not.
There's a 3 in column 5.
There is a 3 in column 5 already, so that is not a 3. And
There's
the
a
7
3 in
looks
row
left.
5 as well.
Okay, I was going to go for the 7 looking left, giving us the 8, the 3, and the 7. And now this 8 looks left and gives us the 9 and the 8. The 8 looks over and gives us a 9. That's a 2. That's an 8 from the row. And
That's it. Yeah.
7 looks down, gives the 8 and the 7. 25 minutes, 18 seconds. That is the correct solution to Darling Fountain. And we remain just absolutely delighted and amazed by the break-in that Brem built into this puzzle. And delighted to have been a part of finishing up the construction of it and getting a chance to do this demo solve of it. We hope you enjoyed it. Please do give a like and a subscribe if you haven't already. It really helps Brem out. His channel is well worth finding, and so the more likes and subscribes, the more likely it is to be recommended to people who haven't seen it yet.
Absolutely.
So, and with that, we will sign out and just say, as Brem does,
Good luck
good luck
with
with
your
your solving.